Hey boys and girls, please just put your headphones in, watch the video, and do your homework. Please be on your best behavior today. So we can get back Monday, we can take our quiz, you guys can be successful on the quiz, and then on Tuesday we can do a little activity for Thanksgiving. So let's do our best just to come in, get our work done. If you finish early, you can read a book for English class. Okay, so today we're talking about identifying proportions from a table. So basically telling whether or not a table is in proportion. So when we use proportions in real life, you probably use them all the time without even realizing it. For instance, when you make a recipe, if you want to double the recipe or halve the recipe because you want to make more or less, you have to keep the ratios or the same proportions intact, otherwise your food would taste funny. For instance, if the recipe calls to mix 1 pitcher of apple juice, it says a pitcher of apple grape juice, holy cow, is composed of 3 cups of apple juice and 2 cups of grape juice. So if you want to make more than 1 pitcher, you're going to have to keep the 3-to-2 ratio the same. Or if you want to make less than 1 pitcher, you still have to keep them in the ratio of 3-to-2, but with less. So you need an equivalent or proportional relationship to 3-to-2. So that would be like 1.5-to-1, something like that. So it shows you here on the table 3 apple juice to 2 grape, or 6 apple juice to 4 grape, 9 to 6, 12 to 8, 3 halves to 1, okay, or 1.5-to-1. And then 1 to 2/3. So the relationship stays constant or proportional even though you're making more or less. Otherwise, it would taste funny. It wouldn't taste right. If you added too much grape juice, it would just taste like grape. And if you added too much apple, it would just taste like apple. So, if a table represents a proportional relationship, the ratios between the 2 variables will always be equal. So all we have to do is divide and make sure that all the ratios are equal. So, if we have the situation with Emery, Emery receives $3 per week allowance. His older brother gets $4 per week. Emery's parents say that it is fair because the allowance is proportional to each child's age. Emery wants to test for proportionality to determine if his parents' strategy is fair. So we have the ages, and then we have their allowance. So this is our in, this is our out. Okay, and that's what you did in 6th grade. In 7th and 8th grade, we call this our x, and this our y. So we always write y over x, or allowance over age. So we have 2 over 8, 3 over 12, and 4 over 16. So I have to see if those relationships are proportional. So I reduce 1/4, 1/4, 1/4. So yes, Emery's parents are correct. Even though they're getting different amounts of money, it is proportional to the age that they are. Okay. So we did step 1, step 2, and step 3 kind of all together on that last problem. So if I do the same steps again, in, out, or x, y, put y over x, and y over x. So I'm putting each y with its corresponding x. I reduce 1/12, 1/10, 1 10 1/3. So those are not the same. Over here, I get 1/12, 2 24ths, and 3 36. 1/12, 1/12, 1/12. So this one, yes, is proportional. So it says, which situation, Matt or Jane's, represents a proportional relationship between the hours work and the amount of money? So Jane's, okay, so Jane's is proportional because there is a constant of 1/12. Or you could call it a constant of proportionality of 1/12. Okay, so the tables below show a proportional relationship. Find the unit rate. So they show a proportional relationship. I know that they're all the same, so I don't have to check everyone because I already know they're the proportional or the same because it told me in the directions. So if this is x and this is y, 12 over 2 would be 6 over 1. So the unit rate is 6 to 1, or 6 miles per hour. Okay, over here, this is x, this is y. They're proportional, so 36 over 4 is 9 to 1. So 9 items per dollar. Okay. Make a table where the constant rate of change is 6 inches for every foot. So if it's 1 foot, 6 inches. If it's 2 feet, it's 12 inches. If it's 3 feet, it's 18 inches. If it's 4 feet, it's 24 inches. So multiplying by 6 each time. Remember, you can pause and rewind as needed. Okay. Next, the information in the table represent a constant rate of change, so it's telling you that everything's constant. Find what's missing. So if everything is constant or in proportion, I can use one ratio to find what's missing. It doesn't matter which ratio you use. So if I do 30 over 2, I set that equal to x over 7. Okay, or you could also do 60 over 4 equal to x over 7. It doesn't matter which one you use. You get the same answer as long as you use the one with the x with either of these other ones. So 2x equals 210. Get your algebraic equation. Divide each side by 2. And x should be 105. Okay, now I have to use this one. I can choose any of those 3 to use. So if I use x over 40, which would be y over x. Okay, y over x. So x over 40 equals, let's say, which one is it? Let's do 13.5 over 20. We'll do the first one. So 20x equals 13.5 times 40, which is 540, divide by 20, 27. Oh, it's okay. I'm just making a video for the kiddos to watch tomorrow. Alright, so in the next group, you're just determining whether the table is proportional. So you're just checking to see that these relationships all reduce to the same thing. So that's your x, that's your y. So you're looking, is 12 over 4 the same as 15 over 5? The same as 20 over the 7? The same as 30 over 10? So 12 over 4 reduces to 3 over 1. 15 over 5 reduces 3 over 1. Looking pretty good until I get to here, and that is not going to give me 3 over 1, even though this one does. So this answer is no, because this does not reduce to 3 over 1. Okay. What else should I show you? Let's look at number 3. Okay, again, x, y. So is 4 over 6 the same as 6 over 9, the same as 10 over 15, the same as 22 over 33? So we take a look. 4 6 reduces to 2/3, 2/3, 2/3, and 2/3. So yes, that is proportional. Let's see what else. And that's it. The rest is your homework. So the homework would be, what page is that? 14, 15, 16, 17. So the homework should be 18 and 19. 13, 14, 15, 16, 17. Yeah, so homework is 18 and 19. So this is page 18. That's your first page of homework. Okay, they show proportional relationship, find the unit rate. So just divide 1 because they told you they're already proportional. Next sentence or next section, you're finding what's missing. Again, they told you they're already proportional. Here you have to divide every one to prove they're proportional, yes or no. Here you're choosing which one's proportional. Here you're finding the mistake, and then answering the questions about the table there. So basically everything is done through division, y over x, or out over in. If you're done watching the video and you do not need to rewind or go back and re-watch anything, please do the homework. When you're done with the homework, please read a book or work on other homework with good, proper behavior that you guys are perfectly capable of doing and I know you can do. Thanks guys, I appreciate it. We will see you on Monday.